So to truly understand experiments, again, considering that we are starting from the very basics here, right? Uh, there is true and quasi experiments. Depends on manipulation created levels. What that means is basically when it comes to experimentation, we had discussed that you have to decide about the variables, the bricks of it all, right? You have to be able to understand, okay, what are my IV, what is my DV or what are my DVs, what is the hypothesis, and definitely what is the nature of the variables that I'm considering, right? For example, gender is like if you consider biological sex, right? It is not a continuous variable as such at this point, right? When you talk about certain variables like exam score or performance on an exam, right? You have to be able to, we had spoken about this word called operationalization, right? You have to be able to operationalize that. Operationalization, by which we mean you have to define it in a way that it becomes measurable, right? So we had said, okay, we can't just go like, okay, memory. What about memory? How are you measuring memory, right? And so there are certain categorical variables and continuous variables. IV is usually categorical. Usually it is categorical, right? So when we come to the examples, we'll understand what we mean by categorical. For example, if I say I want to compare two learning methods, right? So there is no continuous relationship between the two learning methods. One would be shayad rote learning, and one would be something like okay, using mnemonic devices, right? So these are not continuous variables; these are categorical variables, and these are our IV. The supposed cause, right? The thing that we are we're looking to examine what is causing the change, right? That is our IV. It is categorical. It has at least minimum two levels, right? They are also called conditions. Experimental control, whenever these words are mentioned, they are talking about the IV, right? In any research paper that you go through, you'll hear you'll listen, or rather you'll read these words: levels, conditions, experimental control, right? And then when it comes to the DV, it is a continuous variable. Usually it is a continuous variable unless you are taking something like, in experimental designs it is usually continuous, right? So there is usually a score. For example, last time we had mentioned uh, score on an exam, the number of words recalled, right? Response time, frequency, recall rate. These are, or like number of words accurately recognized, right? All of these are, usual indicators that this is the IV, right? The hypothesis is the assumption or the presumption that the IV has some kind of an impact on the DV. Sometimes we give some kind of a direction, right? We had spoken about this in our last lecture. Sometimes we give some kind of a direction, okay, like it has a positive effect or it has a negative effect, or sometimes we simply say that okay, there's just an effect on the DV, right? Today we'll delve into the types of experimental designs a little bit more. True and quasi, we'll also go into a little bit more detail, right? But try to remember this: the IV is about manipulation, right? Or rather, the levels that we have created out of. So I'm so sorry. The levels that we have created. Okay, I just go through. Okay, yeah, I'll just go through some of the other tools and then we'll hop back onto the types of experimental methods. Correlation, we had previously studied it, that the relationship between two or more variables. Something which really exemplifies the difference between correlation and experiments is, or like causation, is that one is a co-occurrence or a coincidence, right? They are occurring together, and one is covariation, right? The causal relationship is covariation, And correlation is a co-occurrence. They are occurring together. They are not having some kind of a cause and effect relationship, right? We had discussed this. Does not imply causation. Ice cream and murders. If you try to remember the ice cream and murders thing, you'll be able to really, you know, keep in mind the fact that, when a correlation is that, it's mentioned that it's a correlation, it is just that, even though it makes very intuitive sense to go like, okay, causation ho sakta hai. Pearson's coefficient, Spearman's rho is sometimes used when we're talking about the population. And advanced level pe regression analysis is often done as a method of correlation, right? And then we have observation as a tool of psychological or research inquiry, primarily observing behaviors and behavioral interaction patterns, systematically observed and recorded. Mary Ainsworth and the study on separation from parent. So, if you remember, there was this experiment that was done by Ainsworth on how does a child react to separation from a parent. Does the child create a lot of, so this was purely an observational study. What happens when, right? Bandura and the Bogod, although it is an experimental study, but still it was a very open-ended and, in a naturalistic setting, right? Bandura and the Bogodol, not so much in a naturalistic setting. It was still a controlled experiment because you don't encounter a Bogodol, right? But in Bandura's experiment, what was done was children were shown some violent materials, and then their response to the Bogodol was analyzed, right? And then the Rosenhan experiment is also a good example, where some researchers who were worried that people were being institutionalized despite being not being mentally unstable, right, or not having disorders, right. So what they did was they faked certain symptoms and then they got admitted to an institution, a mental institution, and then afterwards, when they stopped showing the symptoms, right, they decided, okay, now we're done with it. They were met with uh, this resistance that, okay, no, even though you're not showing the symptoms, but still, so each one of their responses to the, forced, they were being held against their will, right? So any kind of a response from their side arguing that, okay, no, we are not actually, this was part of an experiment, etc., all of those things was not listened to. The main people who were involved in the study had to come and get them out, right? So Rosenhan experiment is a very good observational study. Can be controlled in the Bogodol experiment, can be controlled, can be naturalistic like the Rosenhan experiment, and can have participant observation also. What that means is, even in the Rosenhan experiment, it will be called participant observation. Yani, you become a participant in the study and then you observe, right? Then we have field studies, which are extensions of observational studies, where people are just in the field. So, what is the field? The field is sometimes community. For example, if I want to know sports persons, prep just before their, okay, performance or just before the match, what do they do? What are their rituals, etc. Right? So I'll just be there and I'll notice them. So that is even the setting, okay, like, just before a match, right? Now that is also a field study, right? So field researchers often also conduct action research, which means certain research which is supposed to have some kind of an impact, right? Matlab, it is going to be used in some way, in a very applied sense, right? The data of it is going to be used in some way in a real life setting. So field studies, so going into communities where if I want to actually study, okay, what does water shortage do, right? What does water shortage do to a community? I will have to go to a place where there is water shortage and observe, collect data and observe, right? There are many systematic methods to follow when doing these. It's not just going and blankly observing, okay? And we have surveys. Surveys are usually our favorites. Questionnaires, inventories are also surveys. There are largely close-ended surveys, so which are like our scales, our inventories that kind of provide scores. Like these are more standardized, and we have open-ended surveys which provide non-quantified information, like sometimes demographics, behaviors, behavior frequencies. So these are more open-ended, like okay. So for example, if I ask, okay, uh, if I ask a question like, how do you perceive your relationship with your children? Now, that's a very open ended question in a very open ended survey, right? And very non standardized also, right? Now we'll move on to the main topic of today, which is types of experimental designs. Any questions so far? What happened, Nishita? Okay, I'm assuming that that was an interaction that was registered by the algorithm. All right. Okay. We'll come to types of experimental designs, right? The content that we'll largely cover today is on surveys, observations, and the first one before that, methods of data collection. Surveys are not observations. Surveys are observational studies can use surveys sometimes, but surveys are very usually very quantified. Observation is very basically like observing. You don't have a predetermined set of questions. Surveys are basically the forms that you tend to send out during your master's thesis, bachelor's thesis, etc. Surveys are not observations. When you observe something and note it down versus when you ask a pointed question, right? Even if it is an open ended question. Can you understand the difference? When these are methods of data, yeah, they are methods of data collection. Good studies, or rather I would say action researches, or very applied research, tries to bring in all of these aspects, tries to bring in surveys, tries to bring in observations. These are not research designs, they are methods of data collection. Okay, all right. So largely today we are going to cover true and quasi experimental designs and the different kinds of designs. We'll try to cover till one way and factorial design for today. Okay, ready? Let us start with certain questions for net, right? Tell me, a psychologist wanted to study marital love between husbands and wives in arranged and love marriages. 50 arranged marriage couples and 50 love marriage couples were randomly chosen, and both the husbands and wives were administered the marital love scale. The data should be analyzed by, give me your answers. Please also try to think of a justification for your answer. Okay, many of you have responded. The correct answer is A. Because a factorial ANOVA for independent groups is appropriate here because the study involves two independent groups, arranged marriage and love marriage couples, and analyzes the interactions of these two independent variables, the type of marriage on the dependent variable, marital love scale, right? How much marital love they experience. How many of you got that right? Quite a few of you. Yeah. We'll clear out certain common mistakes or common issues that we have with repeated between measures, all of those things. Don't worry. There are two independent groups here, right? We are comparing love marriage and arranged marriage wale couples, right? And there are husbands and wives ka data. Can you also tell why the others won't be appropriate? Because it doesn't fit. There is no one group that is measured, that is being measured, like, after or before the condition, or like, one group, for example, repeated measures ka condition is that all the conditions are, or rather, all the groups are exposed to all the conditions, which is not what's happening, right? If our IV is type of marriage, arranged and loved, we are not making people go through arranged marriage and go through love marriage, right? That is why it is not repeated measures. Got it? And mixed factorial ANOVA and randomized one way तो है ही नहीं, because there are two uh, IVs here, right? And it's not mixed. There's no reason for it to be mixed also. And it's not randomized. Therefore, it is not randomized one way ANOVA, right? There are no repeated measures. Therefore, only one option. One thing that I would recommend is that that is a very good strategy actually, to when you are about to confirm one answer in your net. I know this can be a bit energy or like rather time consuming, but when you are very conflicted between the responses, try to do this process of elimination, right? I think that would be a good thing for you to do. Okay, we'll move on. An easy one now. Assigning test conditions to one group of participants while keeping others as neutral to test the effect of a variable under study is a practice in research. The group not assigned to test conditions would be known as brilliant, right? C, because C is the correct answer, as the experimental method is indeed okay. The response is not correct, but the control group is the group that is not exposed to any kind of experimentation and manipulation. The control group is somewhat of a baseline or a very natural setting, rather, where you are not technically manipulating anything. Okay, last one. I know these are a little tricky, but this is still an easier one. Experimental method as compared to other methods is more suitable for studying cause and effect relationships. Reason: as compared to other methods, experimental method permits more efficient control of extraneous variance. Correct. One strategy that I often use to answer these type of questions is ask because in the middle. Experimental method as compared to other methods is more suitable for studying cause and effect relationship because as compared to other methods, experimental method permits more efficient control of extraneous variance. If it makes sense, it's more likely to be the right answer. If it doesn't make sense, then cross question, right? Because the assertion is there because of the reason, right? And not vice versa and all. So that is correct. A is correct, as the experimental method is indeed the most suitable for studying as it controls extraneous variables effectively. making the reason correct, right? Moving on to the main content of today. What is an experiment? Experiments are a scientific method, first and foremost, of establishing cause and effect relationships between variables. So, one is it follows the traditional scientific method. Second, there's a cause and effect relationship, and the third, there are variables involved. Right? These three are very important criteria for an experiment. It follows the traditional scientific method, right? In that it is positivist in nature, right? If you remember, the positivist movement talks about what is observable, the nature of reality as gettable, or the truth as something that can be accessed, right? Via observation, via uh, measurement, right? So very high on quantification. We test hypotheses within experiments, and we involve independent and dependent variables in experiments. In correlation, you will not hear this, right? Because we are not trying to establish cause and effect relationships. Features क्या है experiments? What are the features of experiments? Control. Now, internal and external validity, I'm sure you know some of it, but basically internal validity is how much of control is in the experiment, right? For example, if I say ruling out everything else, right? Taking care of all the other variables which can have some kind of an effect on the cause effect relationship. If I really want to find out, for example, whether studying by itself has an effect on exam performance, right? Let's see. Or rather, one hypothesis that was posed also in one of my own classes is that academic achievement seems a bit more like an IQ game, right? And IQ testing also has somewhat of academic components to it, right? So we don't know, again, murgi and anda, like, chicken and hen and egg, the situation is. So the hypothesis was that exam performance is directly related to IQ level, right? And let's not be very reductive. There are multiple other factors, but let's see. If I say I have high internal validity or high internal control, I will try to measure, okay, if I want to really say, okay, IQ has an effect on exam performance, I have to take out studying exams at all, because studying has been shown to have an effect, right? This person will not consume any kind of information about what is going to be in the exam, right? Anything that has an effect or, like, can improve exam performance, I will have to rule out, right? If I am able to do that, then I can say I have high internal control or high internal validity, right? But what does that mean? Are the results generalizable then? Because we don't exist as, just because you have IQ does not mean that by itself, okay, IQ makes you maybe a little more curious, or maybe, you do well in exams, therefore you try to do better also. When you do good in certain things, you tend to like it, you tend to have this kind of a sense of achievement that is associated with it. So even that is going to affect your exam performance and the amount of effort you put into it, right? So is this really generalizable? Answer me this. Because external validity asks that question: is this generalizable to the population? No, IQ by itself does not do a lot of things, but certain things associated with IQ, that is, certain proclivities or certain interests towards academics, or certain other endeavors that you do. Like, if you are doing something or the other at any given point in life, right? There is a book, you will read it. If that is something that happens because of your IQ levels, or like, like something, even something like whether you're, I'm so sorry, 1 second. So sorry. Even your parents' education level has been considered to be one of the predicting factors behind academic performance, right? So I will have to take that away also. You can't really study a person like this and say, okay, the results of this are generalizable. There is no external validity here. Think of internal validity and external validity as an inversely proportional relationship. What I mean by that is, if we say a glass is more full, then it is less empty. If we say a glass is more empty, then it is less full. So, similarly, if internal validity is very high, then generalizability or external validity is low. And if external validity is high, for example, in observational experiments, etc., the internal validity will be very low, right? Not a lot of control. Then we have manipulation. Now, this word may seem a little confusing, but it is basically changing the condition. For example, if I want to study, like, okay, recall, and I want to say, okay, the type of recall has some kind of an effect on how many words people can remember, right? So, changing or manipulating type of recall into I'm so sorry, into two levels or two conditions. So, one, I would say, like, okay, you try to remember by, or you try to recall. For example, I've shown you a list of words and you try to recall in a sequential manner, right? That, okay, the first one you have to say the first, and then you have to go to the second, and then the third, then the fourth, then the fifth. And if I tell you, okay, you can do it in any random manner, you can recall the words that you have seen earlier on the screen in any random manner, right? So this is changing the IV, and manipulation is always done with the IV, right? IV is the cause. What is being manipulated, right? What are we changing? What are we comparing in essence, right? Has a minimum of two levels, categorical type of data. DV is the effect part of the relationship. On what is the effect observable? If I say IQ has an effect on exam performance, on what is the effect observable? The scores, right? Exam performance are being measured, operationalized. Exam performance is being measured by scores, continuous type of data in experiments. These are the major types of experiments. Pre-experiments are the simplest. There is no control condition. There are multiple types of pre-experiments. Bobodal experiment was a pre-experiment. Like, you just bring about a child, you show them a video or you show them some kind of stimulus of someone acting violently, and then you give them a Bobo doll to play with. Do they react violently to it? Right? Effect of taking therapy on mood. Right? There is no control condition. There is nothing here. There is just one condition usually that is being given to you. Right? You're being exposed to a condition. Right? Effect of classical and temporary music on task engagement. Even this is no control condition. And this is true for most Western tests, because even though they are very rigorous and measure a wide variety of constructs, they are most likely never applicable to other cultures, because the standardized study was never on a heterogeneous population, leading to low generalizability on cultures. Yes, but it's not generalizable, not because it does not have, or it has less internal validity. Generalizability, when you're talking about, in what you're talking about in your comment, is about the sampling, right? The sampling is inaccurate. It's not that all the variables are controlled. That is not the reason why there is less generalizability. Make sense? Yeah. Okay. Effect of classical and temporary music on task engagement. I just have two groups. I give one classical music to listen to when they are doing some kind of a task, and one group contemporary music, and then I measure the task engagement. Maybe I ask, okay, like, how did you feel during the task, etc. All of those things. Maybe there is a task engagement measurement scale that I'm using, right? And one shot case study designs. One person, and in that person's life, if you introduce some kind of an experiment, or like, if you induce some kind of a change, or like, you manipulate a variable, right, and then you study the effect of that. For example, taking therapy and one individual, right, before and after therapy, pre-post designs are also very common examples of pre-experiments, right. Pre-post designs can be used with control also, but again, pre-experiments के हिसाब में, or rather within this, is more categorizable. Now we come to two types of experiments where there is a control condition. But the main difference is between random assignment, and that makes a lot of difference, right? In true experiments, random assignment is necessary, right? What is random assignment? Give me, give me some kind of an idea what you have so that we can work with that. Okay. Everyone has an equal chance of being selected to the study. No, that is random sampling or random selection. Randomly assigning participants to experimental group and control group is random assignment. Subject selected randomly for an experiment. No, that is also random sampling. Right? I'll explain this via this. Random selection refers to, okay, if this is the population, I've taken a sample. This is random selection, right? Now I have this sample with me. In this sample, who will go in one group and who will go in the second group? For example, if I have experimental and control groups, right? I will say, okay, one listens to music while studying maths, one doesn't listen to anything, right? So one is control and one is this. If the selection from this sample is random, like, okay, one go here, one go here, one goes here, one goes here, right? Then we can say, like, okay, fine. This is random assignment. Randomly assigning them to groups. You get it? Yeah? Okay, cool. This is the major difference between true and quasi experiments. For example, certain variables are not that easily. Sorry, just one second. Certain variables are not that easily randomly assigned. For example, if I say कि okay, all psychology students, उसमें से मैंने एक sample निकाला, ठीक है? Psychology students of India, different. I have done the most rigorous process of stratified random sampling. Okay? Now, if I want to divide them in gender, and I want to say, okay, like, okay, male psychology students and female psychology students, I cannot randomly assign, right? I cannot assign or manipulate gender here, right? I am not taking neutral genderless beings and then categorizing them into male and female. Non-binary भी है, but Definitely. Here, for like the sake of larger populations, I'm not doing that, right? Gender is one of the major, one variable which is definitely quasi experimental, right? I cannot randomly assign it. I cannot say, so even say, sometimes, like, because of convenience, because of the way that variables exist, right? We cannot have true experiments. For example, sometimes there are ethical constraints. I cannot have uh, the effect of smoking on memory if I want to study. I cannot have one group which is like all non-smokers, and then I tell half of them to start smoking. I cannot do that. Ethically, I can't do that, right? So I can't. So I will have to do a quasi experiment. I will have to find couple of smokers and couple of non-smokers to create my two groups. So it is not random assignment, right? Most of our experiments are based on random assignment, or rather, sorry, most of our experiments are devoid of random assignment, therefore, they are quasi experimental. Unless we take very cognitive experiments like, perceptual wale experiments, psychophysics types experiments, those are rather true experiments where you can randomly assign actually people from the sample into the two groups, or like, multiple groups. But in many of our, so here you can see, as much internal validity increases, external validity decreases, and as much as we decrease the internal validity, the external validity also increases, right? So certain categories or certain variables are not easily randomly assigned, right? In true experiments, control condition is necessary. So it is in quasi experiments also. Random assignment is necessary. Quasi experiments are done when random assignment is not possible, right? There is high control in true experiments. We can manipulate the IV very well. There is not a lot of control with regards to manipulation of the IV in quasi experiments. We can control certain other variables, but we are not manipulating the IV in a very controlled setting. Strong control है तो high internal validity. It is the strongest form of scientific experimentation, also called the gold standard. This was one question that was asked in one of the net question papers also. So what is the gold standard, right? True experiments are the gold standards. Drug trials are true experiments, right? Effects of types of intervention on anxiety reduction with control condition can also be true experiment. We take people who experience heightened levels of anxiety as our sample, and then we randomly assign them to different intervention groups. One will go through CBT, one will go through mindfulness training, etc. Right? Random assignment often can prioritize external validity as internal validity is compromised as both groups are not exactly comparable at a baseline, right? Effect of smoking on memory retention task. We can't induce smoking, right? Manipulation is also called inducing gendered relationships. Whenever we are studying this, it is quasi experimental. Then we come to repeated and independent measures. Repeated measures are also called within group measures or matched pairs. Matched pairs is a very specific form of repeated measures where, so let's see, if I have two groups here, right? Or rather, I have two conditions. Okay? I have the condition that, okay, one is going to study from an Indian book. For no reason I'm saying this. One is going to study from an Indian book, or rather, let's take the anxiety example. One is going to go through, the sample is anxiety or people who report having anxiety, right? Heightened levels of anxiety. One goes through CBT and one goes through mindfulness, right? What is this type of comparison? Tell me. Correct. Independent group design, right? So what I have done here is bifurcated this group into two, and two parts of my sample are assigned to two groups, right? What if I do this? I take all my anxious people, right? And I expose them to both the conditions of mindfulness and CBT. And then I see, okay, after each, how do they feel, right? I take a mood inventory or questionnaire after each kind of intervention that they've gone through. All of my anxious people are being exposed to all the conditions that exist. What is this? Repeated measures. Correct. Matched pairs is where I am technically taking two groups, or sorry, groups है ना? ठीक है. This is my sample. I am making two groups. And these are going through certain different conditions. One is going through one condition, and the second group is going through second condition, right? But these two groups are matched on some variable. What if I example for what if I take anxious best friends, and each best friend, so if I have 10 people here, so each best friend is put into one group. Two best friends, one in one group and the other in the other group, right? And I try to then measure this. This is called, though they are separate entities, but they are matched on one variable, right? So whenever we talk about sometimes couples also, right? Husbands and wives and spouses and partners, right? We tend to do this. Matched pairs. They are matched on some kind of a variable, right? So not only do we get data for individuals, but we also get data for these matched pairs, and we see if any of the matches, even the match is uh, one data point, right? How do both best friends, like for example A and B are best friends, how do their composite scores compare to all the other pairs, right? Comparison of the same group for all conditions, right? Very interesting. In marital satisfaction, yeah, etc., all of these studies, it has become a bit of a preferred method, right, to do this kind of matched pairs design, right? But the problem with this is, for example, the person who went through CBT and then who went through uh, mindfulness training, are they getting better or are they feeling better because of either one of those, or are they feeling better because even in the mindfulness, right, even though they did the mindfulness one later, right, but the effects of CBT will be seen in the mindfulness practice also, right? Some of it will remain. So there are practice effects that are there. There are recency effects, whatever was most recent, primacy effects, right? That is the problem with repeated measures. If one group or one participant is exposed to all the conditions, then practice effects can take place. Whatever is recent is what they remember, or whatever was the first is what they remember best, right? Or has had the most effect, right? So very not easily classifiable. Then we come to independent measures. Now, when independent measures, like I said, the two groups, comparison is between the different groups, but the individual differences can become a problem here. Why? Because, for example, even if I say in a memory experiment, if I'm trying to do, if I say, okay, usage of mnemonic devices to, or memory aids in recall rate, the effect of using memory aids on retention, retention of words, right? Even if I say control, people are not going to actually not use any kind of memory aids. I can never be sure of that, right? So that is one thing, that is because of the nature of the tasks that we are giving. Because of that, that problem is coming, right? But there are always individual differences. When we, that is why we say, okay, if you have a large enough group, the individual differences won't matter. But if you don't have a large enough group, independent measures can wreak a little bit of havoc on, because people are different in essence, right? So we can't say that the effect of the condition or the CBT is the only thing. Maybe certain people are more receptive to CBT because that is their way of uh, analyzing situations or problem solving. Some people might be more receptive to CBT just because of that, not because of CBT ka efficacy by itself, right? Then we have analysis of variance. The main thing that you have to remember with ANOVA is that one way ANOVA has only one IV and factorial has two or more IVs. It can be called two-way ANOVA, three-way ANOVA, factorial design, etc. All of those things. If there is only one IV, it is one-way ANOVA. And if there are two or more IVs, then it's a factorial design. Okay, you have with me so far? I think we have thoda sa come time. Okay, let's see. Let's take the example of I have one IV. Let's take memory aids. Sorry, wait, just 1 second. We'll discuss this and then we'll end the class, okay? I want to study the effect of memory aids on retention, right? This is my IV, memory aids on retention of words or retention of content. I give them a passage and I tell them, or I ask them questions later on about the passage, right? And that is how, and based on the accurate number of responses, I calculate a score for retention. Okay, I'm trying to find out if the type of memory aid used helps or benefits or has a disadvantageous relationship with retention, right? The two levels for memory aids that I'm using are one is rote learning, repeatedly saying it out loud, right? And the other is mnemonic devices, right? We have heard of, like, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. We will say Pluto. Okay? My very eccentric mother just made us, yeah, just made us nice. Sorry, I'm so sorry. I don't remember the mnemonic. I remember the uh, yeah, wait. My very Yeah, my very educated mother just sent us 9 pizzas, right? So that is to remember Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Yeah, my very ego mother just served us noodles. That is Pluto. Okay, now that is a good example of a mnemonic device. Rote learning, noodle plate. Yes. Rote learning would be repeatedly saying Mercury, Earth, Venus, Mars, Jupiter, etc., all of that. Okay? And then I measure in the end who is able to recall this sequence of our planets better, right? Because we are older, we remember it better. But what if I do this with children, this experiment, right? Let's see. So here, what I will be comparing is the people who have gone through rote learning and people who have gone through mnemonic learning and their scores, right? Their scores on the DV, which is retention. So I have two sets of scores for retention. Out of 50, for example, in the rote learning one, 30 students could remember the sequence accurately. And in the mnemonic one, 40 students could remember accurately, right? If I'm doing like, a very 1-0 type of thing, right? 40 is the score. This is the comparison, right? Now I just made it to individual, but what if I had some kind of a score for each planet recognized properly? So the average score if is 30 for this and 40 for this, right? Then on the face we can say, okay, there is a difference between the groups. But then we do statistical analysis to see whether the difference is seen between all most of the participants or not, right? Across. Okay. This is IV or rather one way ANOVA, where there are two levels, minimum two levels, right? And then we try to measure these two groups ka difference. In factorial design, there are more than two IVs, right? Sorry, always more than one IV, right? The example I'd like to give for this is impact of study method, and practicing of test papers on exam performance, right? So here we have two IVs. What are our IVs? Study method is IV1 and practice tests is IV2. Okay, just 1 second. We started 5 minutes late. So I'll just take 5 more minutes of yours. Okay. So this is IV2. Remember, IV has a minimum of two levels. Any IV has to have a minimum of two levels, right? So in study methods, I am trying to uh, study the difference between, let's say, okay. So one long session each week versus multiple short sessions throughout the week, right? This is a study method which is based on distribution of time, right? One long session and multiple short sessions throughout the week, right? I take a group, I take a sample, and I make two groups and I instruct them to, okay, one group to, I instruct, okay, one session throughout the week, one 5 hour session, okay? You sit and study. And the other group I say, okay, 1 hour every day for 5 days in a week, right? That's how I have random assignment also here. So this will be a true experiment, right? If I took people who already use these methods and then I made the groups, then that would not be random assignment. That would be quasi experimental, right? But why would you do that if you can do true experiments, right? And then we have practice test में yes practice test and no practice test. You either do practice tests or you don't do practice tests, right? The DV is exam performance and it is measured by the score that you get on your final between 0 to 100. Cool, right? Remember this. Now there are something in a factorial design called main effects and interaction effects. So we'll technically have four groups, right? Because we have two IVs which are intersecting at two levels. Can you see here? Right? So what that will give us is long sessions and practice tests, or rather let's do practice test, yes, long sessions and practice test, no, short sessions and yes, practice tests, and short sessions and no practice tests, right? So here we have, technically we have four group data, for the data of four groups. What are the main effects? Now let's just number this: 1, 2, 3, 4. If I want to compare this method, right, the effect of the study method, that will be our first hypothesis. The effect of the study method, whether you take one long session or multiple short sessions, which is better in terms of exam performance, right? All of it, the result we are studying is on exam performance, right? So what I will compare is 1 and 2 together versus 3 and 4. Do you get why? 1 and 2 together and 3 and 4 together, right? So we'll have technically two groups. And with this, the difference between their average scores will tell us which one is better, right? Now, similarly, if I want to do for practice tests, like, if I really want to say, is there an effect of practicing tests or doing practice tests on exam performance? I will take 1 and 3 and 2 and 4. 1 and 3 and 2 and 4 versus 2 and 4, right? This will be our second hypothesis. Both of these are called main effects, right? जो हमारे main IVs हैं, the main IVs that we have, it is studying the effect of or the difference between the main levels in the main one IV, right? Then we come to something called interaction effect, right? Which is here. This is the beauty of interaction effect. What we will try to figure out is, we'll treat each of these as four distinct groups, and by statistical inquiry, what we'll try to find out is this kind of a relationship. Or wait, rather let me right. We are supposed to get something which is like this, right? So multiple short sessions with practice papers, multiple short sessions with no practice papers, one long session each week with test papers, and one long session each week with no test papers. This kind of a relationship is something we can get out of studying interaction effects, right? This will be based on the score on their exam performance. We'll get data for each group, right? And then we compare the interaction of each of these variables, right? So again, this is not based on like a real experiment, but one thing we can say is that multiple short sessions, because it helps with memory consolidation, etc., right? And solving test papers has been proven to enhance exam performance scores, right? Can be the best strategy. Multiple short sessions with no test papers also still can aid memory retention. One long session with test papers because test papers are usually beneficial. ठीक है, that will give an intermediate score, and the lowest score or the least beneficial strategy according to this would be one long session each week with no test papers, right? So this kind of a relationship we can only give via doing a factorial analysis of variance, right? Is it clear? I hope it's clear. Okay, great. We'll end the class today. We'll just go through some test questions, right? Imagine you are conducting an experiment to test the effects of video gaming on learning and attention. You select four groups A, B, C, and D with the following video game hours. Which of the following group serves as the control group in the experiment? Correct. Again, this was the yeah. Moving on. Now this is a difficult one, right? The emic-etic distinction is emphasized in quasi-experimental research, ethological research, case studies, or ethnographic research. D is the correct answer. Now, this was a little difficult. Here we talk about the emic ethic is essentially about a lot of when we talk about observational studies, etc., and when we talk about participant observation, right? In ethnographic research, we talk about this idea, the emic ethic, by saying that people who are within the community have some kind of a privilege in terms of understanding their own knowledge systems, right? For example, a British person coming in and studying Indian culture versus an Indian person studying Indian culture. Ethnographic research follows that much more, right? Used in ethnographic research to differentiate between insider and outsider perspectives regarding cultural phenomena, right? If we were to do this, for example, if we were to compare insider and outsider perspectives regarding cultural phenomena, right? What would we be doing? Would we be doing a true experimental research or a quasi experimental research? Correct. Why is it quasi Shambhavi? Can't randomly assign. Definitely. Why? Yeah. You can't alter the IV, only select it. We can't make people insiders and outsiders. We can't make an Indian person British and a British person Indian. Yeah, they're already in it or out of it. Correct. Last one. Does relationship skill training or mindfulness training have a significant impact on couples' marital satisfaction? What kind of a comparison would this be? Please take a very close look at the wordings. Does relationship skill training or mindfulness training have a significant impact on couples' marital satisfaction? What kind of comparison would this be? Pay close attention to the words. B is the correct response. Matched pairs. We are not talking about, we are talking about the couple's marital satisfaction here. We are taking the couple as a matched pair.